AQA, GCSE, Combined Science, June 19, Paper 1, Question 3. So, hybrid car has an electric motor and a petrol engine, and petrol is non-renewable. That means it'll run out. And you could say it will run out, and you get the mark here. Technically, you want to say that it can't be replaced or can't be replaced in our lifetime. The mark scheme went with replenished, so it can't, it cannot, or can't be replenished. Next one, electric motor in the car powered by a battery, plugged into the mains, 230 volts. I won't even read any further, I'm just going to mark down that that's V if it's volts. Power to charge the battery, 6.9 kilowatts. Unlike the previous question, there was nothing there to hint that I should leave it in kilowatts. There's a fly on my finger. Hello fly, go away. So I'm going to change that to watts. So that's 6,900 watts. And that's also P for power. And we want the current I. Hopefully you remember PIV. Paul is vain. P equals I times V. So that's going to be 6,900 equals I times 230. Put a little time sign in there. 6,900 divided by 230 then. That's going to be 30 amps. And that's my current. Simple. Right. This would answered terribly. So AC and DC, direct current and alternating current, or direct and alternating potential difference. Right, DC was simple. Most people could answer that. In a DC circuit, the current flows in one direction around the circuit. But in an AC circuit, most people wrote that it goes in all directions, or this way and that way, but it can't go more than one direction at once. So it goes this direction and then it goes in that direction, one after the other, and it keeps changing between them. So DC, the current goes in one direction. AC, the current keeps, and the emphasis here, this is the important bit, changing direction. You just need to learn those definitions. Right. Next part of this question, is it the last part? Yep, last part of this question. It says it has a low resistance. So if the cable's got a low resistance, the current can flow through it easily. It doesn't cause it to warm up. So you need to think how that might affect things. So if it's got a low resistance, it won't heat up. There's multiple ways of answering this, but I think this is simplest. And if it doesn't heat up, we won't waste as much energy. Waste as much energy. And you can ask me about that one. Oh, I've spelt waste wrong. Waste as much energy. That's the end of question 3.